After learning how to create vectors, we can take a step forward and look at matrices. And we are not that far off because actually vectors are a special case of matrices. A matrix, a typical two-dimensional matrix, would be having, let's say, n rows and k columns. And so vectors are special cases, so we can have a row vector which is, so here we say that it's n times k. So a vector having one row and maybe k columns is basically 1 times k. Or we can have the case when it has many rows and just one column, so that it is n by 1. So row vector, column vector, but they are still matrices, just special case of matrices. So that helps us because it means that the rules in creating matrices or in creating rows apply to matrices. And so if we want to create a matrix, we can, for instance, combine different rows. So we already know how to make a row vector. We are separating specific elements with commas or with spaces. And then we are just telling Matlab that it's supposed to add more rows to that specific row. So if we have a whole one row, then after semicolon we can place a whole other row, and after another semicolon another one. And of course we then don't have to limit ourselves to 3 rows only. We can have as many as the matrix needs. So that's one way with the semicolons. Once again, please notice that the role of this semicolon here within array creation is different from the one at the end of the line of the code. And then a second way is just by using enter. So if you prefer to see your matrix like as if it would be written on paper, so you can just use enter to write the rows one under another. So for instance, here is one example using this first case, how we could create a matrix, and then Matlab would display it for us like this. But I also could have written it this way. So I say 5, 35, 43. And then after pressing enter, I would have 4, 76, 81. And after another enter, 21, 32, and 40. And so after I pressed enter, I would get the same result as Matlab shows here. So the rule is simple. Space means new column value, so we move on in the same row. And then once we have a semicolon or a natural enter, it means Matlab goes down to the next row. And of course, matrix elements can also be created not by giving it specific values directly, but some sub-calculations or using values of previously defined variables. So for instance, I would have a matrix here which has 6 elements. It's 2 by 3, and the elements are a combination of some previously defined variables, maybe some direct arithmetic operations, or directly given numeric values. And same as with scalar variables, as long as you have a value which is integer, then Matlab will display that one as integer. But if at least one element in your entire matrix has some decimal precision, then the entire matrix is displayed this way. So for instance, even though this first element is just 3, then Matlab adjusts the display format to this one value, or actually there are 2 of them, this one and then the one 0.5, which are non-integer. So then the entire matrix looks like this. Then there is yet another example. So now we are combining 4 different rows. We have one row where we have numbers from 1 to 11 with step 2, and so that's this one. And we are using this colon operator. Similar way here. So we have numbers from 0 to 25 with step 5. And then we have another example. So we have 6 values from 10 to 60. So now we're not defining the step. Matlab will calculate the step itself. It just knows it's supposed to produce 6 values. And then we have one more, which is just a directly written set of numbers. So altogether, combined, they bring this. Once again, errors can happen. And one example is here. So we are trying to create this array. We have 4 values here. Then we have linspace where we tell we want to take numbers from 1 to 4 and to have 3 of those. So now we can see there are 4 elements in here, but only 3 in here, and that should already be a problem. Let's check the last one, 2 with step 2 up to 8, there is 4 of those as well. So this message about inconsistent dimensions means exactly that you are trying to combine rows that are not of the same size. In Matlab or even in math, you cannot have a matrix which has an empty element, because this would mean we are trying to create something like this. Then there would be 1, 2.54, and then 2, 4, 6, and 8. You cannot have a hole in here. It would have to have a value. Even if you don't know the value, then you define it as not a number or something of that kind. But since it can't be just empty, then we get this error. Another trick which may sometimes be useful is that you first create your array as empty and then you keep adding elements to it. So like in here, we define v to have nothing inside, and then as loop goes on and keeps values of I from 1 to 10, it keeps adding those values. So how the loop works, first it takes I equal 1, and so our vector will become its previous value, which means empty, and the new value I here. So that results in one element array. Then the loop takes another step, I is 2, and v becomes what it was from last step, and the new element. So that results in 1 and 2. And when I is 3, then v is what it was, so now it is 1 and 2, and the new element, 3. So the resulting is 1, 2, 3. And it will go on like this up to I is 10. This is commonly used when you have to, maybe you have an array from which you have to pick elements based on some condition, and you don't know in advance how many will satisfy that condition. So you just keep picking them one by one and adding into your result array. Matlab also has some ready functions for creating so-called elementary matrices. Those are I, zeros, ones, diagonal, and rand. Let's look quickly what they do. So zeros function creates a matrix filled with zeros, and you have to specify the dimension for that. So always rows first and columns. So 3 rows in here, 4 columns in here. In case you give it only one argument, for instance, let's say 5, then it will create matrix 5 by 5. So like a square matrix. That's possible. If you want just 5 rows or 5 columns, you have to remember to say it's 1 by 5 or 5 by 1. That one has to appear. Otherwise, you will really get a square matrix. There is a respective function ones for creating a matrix filled with only ones. Once again, rows and columns. And if you give one input, you will get a square matrix of the specified dimensions. I function creates so-called identity matrix, so it means that it has zeros otherwise, but it has ones on the diagonal. So this is mostly used for square matrices. However, if you need a non-square matrix, that it will work so that it will still start from the diagonal and it will keep filling it up to the last available row or column. The list mentioned also diagonal. So this one means that if you have, let's say, matrix A, which has elements 1, 2, 3, and 4, then this diagonal of A would return you a matrix 1 and 4, so it picks those which are on the diagonal and fill everything else with zeros. And rand, for instance, creates a matrix filled with random numbers, in this case uniformly distributed on interval 0, 1. So for instance, if I say rand 3 by 4, I will get a matrix with 3 rows and 4 columns, where each number in this matrix will be a random number with value anywhere between 0 and 1.